up if you know what observability is. Okay, there's a few hands. So even though you put your hands up, my guess is that the person next to you has a different idea of what it is. So let's first start with a recap. So observability is the ability to measure the current state of a system based on examining its outputs. Well, let's say that's the official definition. Oh. For software, we usually, when we're talking about observability, we're talking about these things. We're talking about metrics, logs, events, and traces. And why do you need that? Well, systems nowadays are becoming more and more distributed, and just looking at a log file to understand what's going on is not enough anymore. You need to have something in place, and you need more of this stuff to be able to understand what a system is doing while it's actually running. And that then can help you understand its behavior. It can help you find problems and debug what's going on. It can also help you locate performance bottlenecks and fix them. Now, to sketch a bit more context, observability is a property of a system, like testability. It's not a tool or something that you can get. It's a property of the system that you're running. And if you look at some other terms that you hear a lot in this field, you hear monitoring. Some people think this is the old-fashioned way of doing it, but to be honest, monitoring is just a part of observability. It's the act of looking at a system over time. So it's just part of if you want to improve the observability of your system, monitoring is one of the things you have to do. Then APM is something you hear in this field quite a lot. Also linked to tracing, those kind of things, but actually it's again just a set of tooling that helps you monitor the performance and availability of your applications. Usually focus a bit more on the applications and less on the infrastructure. And then there is a whole set of security-related stuff that's also mentioned, or some of the vendors in this field, they also have tooling around this. And that's a whole lot of talk, so I'm not going to touch on that this time on this talk, but just so you know, that is also usually a link to this, but out of scope for now. So my name is Nico Krijnen, and I work at a Dutch consultancy company called Luminis. And my mantra is to try and keep things simple, even when you're facing complex problems. And we're facing a lot of complex problems nowadays. And in the next half hour, what I'm going to try and do is give you the right ingredients to get you started with observability, right? Increasing the observability of your systems, and keeping that simple. And you may have heard everything that I'm going to say. There's a lot of stuff and a lot of places that I see, though, that seem not to be aware of these things. So these may sound, in some cases, like basics or like, yeah, I know that. But I think it's really useful to share this because I also see a lot of people are not aware of these things. So let's start with the ingredients. So to do observability successful, you need to do a few things. So let's start with structured logging. So this is an important piece. And usually when you look at logs, they look a little like this. So they're quite somewhat human readable, but they're actually really hard to interpret by machines. So what you then need is to extract meaning from these logs. It's quite hard. You need quite some processing power, and that means you're going to be burning a lot of CPU just to process and figure out what these logs mean. And then you store and visualize them in some tool that you have. But yeah, you need to do all this processing, right? And you need to configure all the processing. So what if you can do this in a different way? And this is where structured logging comes in. So the idea is that at the source, where your application logs, you don't just log these lines that you just saw, but you log typically JSON lines with a specific structure in there. So each of the things is a field in there. And as you can imagine, this solves a lot of the processing. You don't need to process it anymore, right? Because the computer can extract meaning from it. And it also solves things like stack traces, right? Being multi-line and now they're just one field. So that means you can get rid of this part. So a tool like Logstash, which is typically used for this processing, I would say you don't need it. You just want to have your logs in the right format, and then you can just ingest them straight away. And that saves you a lot of configuration, a lot of maintenance, a lot of resources on CPU, right? So is just using JSON enough? Sadly, no, it is not, right? Because if you can see these two, they're both JSON, but they're both very different in format. There's different fields in play, and it's still going to be hard to figure out what they're meaning, right? You need to assign meaning to each of these different fields. So what can we do about that? So use standardized JSON logs. And OpenTelemetry is still working on a spec for logging. But in the meantime, vendors like Elastic have defined a thorough set of standard fields. The Elastic Common Schema has over 400 fields defined for pretty much all the stuff that you typically want to put in your logs. And creating consistency like that in their source data can really simplify the complete setup of your observability. And it will help, well, avoid complexity down the line. So when we're talking about tooling and vendors, there's a lot of open source tools in this area. There's a lot of vendors in this area. And they're all there to gather all this telemetry, right, and make it searchable and get insights from it. What I typically see is people trying to stay away from vendor lock-in and those kind of things, and that's a good thing. But it also means that in a lot of cases, when you try to do that, you're missing out on a lot of the vendor-specific functionality, right? You're keeping everything generic. You're not gonna get everything out of it. Now, OpenTelemetry is on the horizon, but not mature enough yet, at least not everywhere yet. So we'll dive into that a bit more later. And then going to collectors. So if we're just talking about logs, there's a lot of things you can do there. There's a lot of tooling that you have. So we talked about Logstash. The famous L part in the Elk stack. It's nowadays actually quite obsolete. So a lot of people still talk about this. You still see it around in blogs and those kind of things, but I think this is not something you actually want to use still. Then there's FileBeat, MetricBeat, which is also from Elastic. A bit more lightweight shippers, I say. Fluentd, you'll use a lot in the Kubernetes space. Again, lightweight, especially Fluentd, and vendor neutral. But it only takes care of logs. There's no metric collection, so you need something else for that. Then vectors from Datadog, and Elastic Agent from Elastic again. And we'll look at the last one a bit more in depth. And then all these vendors, so you can see a bunch of other vendors there, they all have agents that you can run on your machines to gather all this stuff. So that's how you typically collect the data. So more about these agents. Most observability vendors, they provide agents to handle data collection. So you install the agent in your host. It'll take care of logs and metric collection. And then in Kubernetes, you typically run these as a daemon set so that each node runs one of these agents. And then for trace and metric collection in process, you typically need something running within the application process. And most vendors offer such things, like instrumentation libraries that you can embed in your application. They usually offer them for various common programming languages. So you usually have these two components in there. Okay, so that's for collecting. This is a really important ingredient, right? So the next ingredient is alerts. Because you can, what I usually see people do is they start setting up nice dashboards with all these metrics that they're now collecting. But to be honest, yeah, they look nice on the wall, but who's actually going to watch them all day? Nobody's, and you don't hire people to watch your metric dashboard. So typically the industry, what we nowadays think is better, don't create dashboards, or you can create them, but focus on creating alerts, right? You want to do something and so they take action based on the stuff that you're collecting, and that's where these alerts come in. But when you have alerts, it's important that you tune them. So if you have an alert and you put a certain threshold on it, and this is the kind of behavior you're seeing, there's actually something going wrong there, but it's not catching it, right? Because the threshold is just a little bit too high. So what you have to do there is adjust the threshold to be low enough to catch the things that are going wrong and ignore all the rest. The other thing that can happen is that your alert threshold is too low, and then it's actually firing on a lot of cases where there's nothing happening. And then obviously you want to adjust a little higher just to make sure that you're just in the right place, right? So, and this is something that changes over time. Maybe your behavior of your application changes over time. So it's best to just, let's say, schedule a quarterly or monthly checkup. So you just check your alerts, see if they're still in the right stage, and if they're too high, just adjust them a little bit lower. If they're too low, you'll probably notice quite soon. So typically, you'll adjust them quicker. So another ingredient that's really important is to know what to log. This is more on the application developers side of things typically. But if you have lots of logs or you have no logs at all, then either it's way too noisy and you can't find anything in the haystack, or you don't have any insights, right? So it's really important to get this right. And it's too much to talk about right now. But look at this talk from Mark Seaman. He has a really excellent talk about how to find exactly the right spot on what to log, in which locations, and what kind of information to make sure that you really get the insights that you want to have. Okay, so that's for all the ingredients. Now, we want to make it work, right? So the first thing you actually want to do is know what your needs are, right? It's super easy to ingest terabytes and terabytes of observability data, but the costs for these solutions typically rise with the amount of data that you keep in the system. So it's really important to know your budget, right? What kind of cost can you spend on this? And then adjust based on that, right? So it would be a waste if you do all the setup and then you figure out that you can only keep 7 days of retention of data because that's what your budget allows you to keep. And then know what your organization needs, right? Maybe 7 days of retention is fine, and then you're all good. And a good observability setup is not going to be cheap. So make sure that whoever controls the budget is aware of this. And you typically will need to do some talking and convincing and explaining to help them understand what kind of value it brings. And also put yourself in their place, right? So maybe you don't need to spend all your money on a super deluxe observability setup. Maybe there's more important things that your team should spend your money on. So maybe you keep the observability setup simple for now. So these are things you have to weigh in, right? So all trade-offs. And then when you start small. Create a spike, take one service, make sure you get the whole chain working, right, from ingestion into the system. Make sure you fine-tune the stuff that's getting in there, that there's no weird stuff in there, or that you're getting the right kind of insights. And then once you finish that, and this, I mean, again, this sounds like an obvious thing to do, right? But I still see people just rolling in the whole solution. So start small, spike one service, and then once you have that, create sort of a blueprint for all the other stuff, and then you can roll it out through all your clusters or all your services. And then there's always going to be that service that's going to work just a little bit different than you planned or that you figured it would. So also make sure you have a bit of room to adapt and adjust. So now let's get building. We'll start by collecting logs and metrics. And in this case, just to make it a bit more concrete, as a sample, I'm going to use Elasticstack here to gather all the stuff in there. You'll see with other vendors, it's going to be fairly similar. So, but this gives it a bit more, makes it a bit more concrete. So how Elastic works is you have this component called Elastic Fleet. And it's quite a different sort of approach from what I say a few years ago. And you still install agents to collect all the data, but where before you install the agents, like the beats and stuff, and you had to configure them, and when you wanted to change the configuration, you have to change the configuration of all these agents. Nowadays, you essentially configure Fleet to tell you what kind of configuration you want, which sort of a central place, and then you install your agents, and they essentially connect back to Fleet, get their configuration loaded in, and then they send back the observability data that you want from them. And if you change your mind, you can change the configuration centrally, and it'll send out, publish that to all these agents. They will update, and then they'll get that new data. They'll readjust their configuration, and then send back the data that you want, obviously. So a big benefit here is you get a lot of integrations out of the box. So there's a lot of tools that the Elastic team, in this case, have already figured out how to collect metrics from. So you can just say, oh, I have a MySQL or a MongoDB. I want to get the the metrics out of that. You just enable the integration, add the configuration, and push it out to the agents, and they will collect all that data. And we'll get back to those integrations a little bit more later. The nice thing about these integrations is that they're sort of working out of the box. The downside, I think, is the configuration is managed for you by the Elastic team, which is good on one side. The other thing is, if you really want to have your own configuration or adjust it a little bit, then you have to go from scratch and you have to just do it all yourself. Still possible, but it's a little harder. Okay, so that's for that part. But I think in the end, the big picture is it does actually give you quite a lot of benefits. So if we're running this in our Kubernetes cluster, this is a bit too big to see. But let's zoom in on this part where the agent's collecting data. So there's an agent running here. Essentially, as I said, right, every node is running this agent. It connects to the fleet of Elastic, then grabs its configuration, and then it just starts up metric beat, a file beat, and an APM server based on the configuration that you want. And then it starts collecting logs from that node, right? So all the Kubernetes logs are going to be there. It'll just read those and tail those and send it all off to fleet. Then there's another component in there. Yeah, so it talks to it, grabs the stuff, and starts it up. Then the other part is when you look at these integrations, they don't just give you the metric collection and configuration, right? But because they already know what they're collecting and what that data is going to look like, they also offer you stuff like dashboards. So the dashboards, the visualizations, all these things for a specific kind of, let's say, Mongo, is all part of that integration. So you don't have to set these up. They're all, once you enable the integration, it also knows how to visualize all that stuff. And here you can see it in action. So really adding another, like, adding observability for another part of your system. It's just a matter of just doing a few clicks in the Fleet UI. And then in the end, when you press save, it'll just send that out, that configuration to all the agents, and they'll start collecting that data. So this is actually quite easy for adding stuff, right? And obviously you'll have to configure a few things here, but it's still a lot easier than creating all the configuration, figuring it out all out for yourself. So next up is collecting traces. And for these, we typically need a bit of extra instrumentation. So I talked about these agents that you run inside your application. So in this case, if we're talking about Java, for example, then you can run this Elastic APM agent in Java. And again, all these vendors have similar things. And that will actually instrument the code. So all the libraries that you load in your application, like Spring or some kind of metrics or HTTP clients, it'll add code to that library to essentially create or extract the information and collect the information that you want. And especially in an ecosystem like Java, this is really nice because there's a lot of common libraries and tools, and this approach is really, really powerful. So without any additional work from just adding the agent, it just adds code to intercept incoming, outgoing requests, and then use that to add trace headers, for example. And then you get really interesting spans and traces like this, right? And for example, it adds information about SQL queries that you're doing with the SQL libraries that you're using, like Hibernate or those kind of things. And then it also collects all sorts of metadata. So you can even, for example, if there's an API call, you can have it trace the body of the API call if you want to. It's turned off by default, but you can turn on these things and it will just work for the whole service. And the key here is you don't have to change the code of the service to do anything, right? You just add the instrumentation library and it just adjusts the code of that service to do all this stuff. Really powerful, really a lot of insights. And then another bonus of running this Java in this case, APM agent, is it also collects metrics from within the JVM. So you don't just get the generic CPU memory that you would normally already get, but you also get, in this case, JVM heap and non-heap memory. You get thread counts, you get garbage collection insights, and that's typically all the stuff you really want to have when you're looking at a JVM application. I remember the times when we used JVisual VM to debug these kind of applications, but you have all that information right now here in your observability solution, right across all your services running. So the last part of making it work is fine-tuning. So the first thing is to enable JSON logs in ECS format, and again, that APM agent is quite useful there. With just some configuration, you can tell it to change the log output of these applications, because it knows the logging libraries, to change that to the output that you want. And then searching and filtering, once you get data flowing in, you can really use the power, in this case of Elastic, to tweak, okay, what kind of data is flowing in, what kind of stuff do I see in there, do I see any anomalies? And then you can probably, well, tune stuff at the source. So for example, in this case, if you look there at the log level, you can see there's 3 values there, info, error, and warn, but the case is not consistent, right? So maybe you want to go back to either to your source and fix that, so they all log in a consistent case, or otherwise, if you can't do that, at least you can adjust the field to be case insensitive when you're searching on it. And then there's weird stuff going on. Like sometimes some services you have their own JSON format, right? And I already told you don't do that. But anyway, sometimes they do, and then they do these kind of things. I'm not sure if you can see what's going on. So the first line that's being logged has a data attribute with some, let's say, a JavaScript object in there with all sorts of properties. And the second one actually has a string in the same place. So these kind of formats are incompatible with each other, and Elastic will essentially ingest the first one, and when the second one comes along, it says, yeah, this is a format I don't, I sort of learned your format, and now you're sending me something different. I don't do that. And it starts dropping the event. So A, this is not so nice from the Elastic side, but B, also, if you have consistent source data, that really helps. And then once you, especially with Elastic, what you have to do is make sure that all these fields are configured. So we talked about this ECS format a while back. That's really good. We actually used a bit of Terraform code to automatically put that configuration into Elastic for all our clusters we have. But it's important to do that part. I see a lot of people just running with dynamic index mapping, and that doesn't work. And then once you have data flowing in, you can use that to evaluate and tune what you need and what you keep, right? And what you can actually throw away. So data, or essentially the log data over time, becomes less relevant. So you can probably tune it a little bit. And you can also figure out, okay, maybe the logging from my low-level infrastructure is less relevant, or maybe more relevant, depends on your use case, right? And another tool you can use in the case of Elastic, as an example, you can use rollup jobs to reduce the density of your metrics. So say you have metrics logging at every 10 seconds, but maybe a few months from now you only want to have it for every 5 minutes or every hour, then it can essentially just reduce the amount of storage it uses by reducing the density of the metric that you have. And then for traces, if you trace every request, you're going to get a lot of data, trust me. So typically, you configure it to only create a sample of the traces. And then, so these are important things to know, right? So don't just trace everything, create a sample rate, and then only take a percentage of that. And maybe do trace all the failures, right? You can do that. So if it's a failure, then it will trace. If it's good, then only sample a percentage. And then the last thing I already talked, right? The value of data becomes typically less when it ages. So you can use this also in data tiering. So with a lifecycle policy, you can put your recent data on hot storage. And then as data becomes older, you put on warm, cold, or frozen data. And typically the price of that storage also reduces as your data ages in this case. Because otherwise, you're typically not going to be able to keep all that data for a very long time, because it's just going to be way too expensive. Okay, so that's all that you need to get observability working for you. And now, before we finish up, there's one last thing that we need to talk about. There's this really cool project around. And so why have we not used that, right? I mean, OpenTelemetry is there. And I haven't really talked about using it. We're just talking about all these agents and collecting stuff, etc. Now, with the rise of microservice architectures and cloud adoption, the infrastructure landscape with many software systems is really becoming more and more diverse, right? There's a lot of different pieces in your system. And the systems are also more and more distributed. So just looking at a log file or some system metric, just no longer an option. So you need to gather everything in one place to get a complete view of what's happening. But the diversity of logs, metrics, and trace data produced by all these different technologies that you're using makes it really hard to capture and collect all that data together. So this is where OpenTelemetry comes in. So they're creating standards for how we store or send and distribute or collect these logs, these traces, and these metrics. And you can imagine if all the systems that you have are still, there are going to be different pieces in your complete service, but at least if all of them output stuff in the same format, then it's much easier to collect. So OpenTelemetry, they started with a standard for tracing, and they're now working on metrics, and they'll pick up logging later. And it may seem a bit like an odd order, but it makes total sense, because after all, the biggest problem around compatibility between systems and data collection is in the tracing space, right? Because there you're talking about creating trace across different applications. So the standard really adds a lot of value there, and that's all, as you can see, it's all stable, it's all there, and you definitely see a lot of people sort of starting to use it in that area. And a lot of vendors, I'd say, are really embracing this. You also see all the cloud vendors, they're really picking up on this part of the initiative. But on the other hand, there are still a lot of places where it's not really being used yet, right? So, for example, if you look at Nginx, a common example, so the Nginx actually has OpenTelemetry support, but the Nginx ingress controller for our Kubernetes, it doesn't yet, right? So it's still probably going to come somewhere later this year, I'm sure, but it's not there yet. So if you want to use that or collect it from there, it's just not going to work. So it doesn't stop you from running it, using it for your own services, but still, I would actually say for now, just stick with the vendor tooling that you have. It's really going to be the easiest to set up, but you can definitely use OpenTelemetry as a fallback, right? If your vendor doesn't support your language for some reason, then OpenTelemetry is definitely a very good fallback. And obviously, hopefully, that situation will improve over time. So when more and more people start adopting this, it'll become hopefully an industry standard that everybody works with, and then the whole collecting observability data will become a lot easier. So the key takeaways. Getting observability working can be very complex, but it doesn't have to be, right? If you're smart about it, you can really keep the whole setup quite simple. And then where you control it, make sure that you apply some key practices, right? Like uniform logging, and that will again help you to keep everything simple. And while you're deep down in the trenches of getting all the technicalities working, don't forget who you're doing this for, right? In the end, there's teams that need this insights. There's end users or customers that they are supporting. That's the goal that we're trying to achieve here, right? We're trying to improve the service of the whole system, and that's the reason for doing all this, right? So just keep in mind that that's what you're doing all this stuff for. So that was the story, and hopefully I gave you some insights. And don't hesitate to look me afterwards. And maybe we can have time for some questions now.
Yes, we have time for questions. I already opened them. Let's see if we can see them here. Thank you, Nico. First, can observability tools handle or manage sensitive data in logs?
Yeah, really excellent question, because that happens quite often, and it depends on the tooling, right? So quite some of these tools, they can definitely take it out of your logs, so they can let's say detect this kind of data and then take it out or like scramble it. To be honest, I would advise to educate your teams so that they don't put these sensitive data in your logs to begin with. Because in a lot of cases, you don't really need that data in your logs. Maybe just put a generic user ID in there and not their email address, those kind of things. And that already can help you a lot in keeping the whole system safe, right? If you don't store data, you don't need to worry about the information security.
Okay. Having agents is not desirable. Can this be done in an agentless environment?
Yeah, good question. So there's a lot of talk about agentless, right? And what I've seen so far is most of these solutions are still really working on agent-based setups. But I think with OpenTelemetry coming up, I think, and maybe there's going to be more API standards, etc., coming in there. So then hopefully we can do this in an agentless setup. That would be really nice, yeah. But so far, what I've seen in practice, just not there yet.
How does the overhead of Elastic Agent compare to other solutions, sidecar-based or daemon set-based?
Yeah, so Elastic Agent is a daemon set, right? So that's the same. Mm-hmm. And then if you look at sidecar solutions, I say a lot of sidecars just add even more because every pod actually gets a sidecar and not every host. So a daemon set is typically actually easier. But yeah, there's going to be some processing, but typically actually it's quite doable. I hope that with OpenTelemetry coming up, that there will be less and less processing involved in all that stuff, because the agent in some case still has to process the logs to grab them out of there. So obviously the less processing, the better the source format adjusts to what you need in the end, the less complexity you need in the all sections in between. And then hopefully these agents or these collecting methods will become more lightweight. The Elastic Agent is not super lightweight. I think something like Fluentbit is definitely a lot more lightweight. But yeah, it also doesn't offer, it's just a fraction of the functionality if you look at that. So.
Okay. What do we have? Can you centrally manage your agent configuration via Git or Terraform?
Yeah, really good one. So as you saw, the agent configuration, you actually have two options. So either you configure it all yourself manually, or you send it out, then you can definitely do it like this. Or you use Fleet, and then Fleet manages the configuration for you. And in the end, I don't think there's official APIs from Elastic yet for this Fleet configuration part. I hope they'll come so that we can actually do this through Terraform. We did use Terraform for a lot of the setup that we did in Elastic, like the alerts and some of the custom dashboards that we created, or like the index mappings and those kind of things, retention policies, all that stuff you can actually manage through Terraform. Yeah, so that's quite nice. And we use the CDK for that, a nice little project that we did there. Works really nice.
Which open source tools, if any, would you recommend when it comes to APM and synthetic mentoring? Monitoring, wherever mentoring comes from.
So synthetic monitoring. To be honest, I haven't really looked. So as Luminis consulting company, it depends which clients I touch, right? Which kind of technology I'm running with. So I have done a lot of stuff with Elastic, as you can see, which is partly open source. But as you probably know, a lot of the, let's say, more full-featured stuff is not free. And then if it comes to open source tools, I think it's good to look at one of the earlier talks from yesterday. I don't remember the name, but there's one where with a really good talk on some open source tooling around this area.
Okay, session's very close to its end, so we do the last two questions. How can we keep alert fatigue under control?
Yeah, interesting. So I already gave some hints, right? So keep tuning your alerts, and then maybe you get tired of tuning them. So yeah, you can still get alerts, but the tuning part is really key there. And what's really interesting in this is there's quite some development in the machine learning space here in this area. So there's quite some places where you, as I said, right, you have to regularly check up on your alerts. With this machine learning stuff, there's less and less need to do that because it will actually figure out the anomalies for you. And you don't have to do that yourself anymore. That actually works quite well. I think it probably can do a bit better still, but yeah, I mean, this stuff is accelerating and developing quite quickly. So looking forward to how that's going to help us there.
Okay, last question. How many logging libraries support OpenTelemetry for generating contextualized logs?
I don't know, to be honest. I'm not sure if you need a specific logging library for that. You need to have the right output format, right? But as I saw, right, the SDKs for OpenTelemetry are still in draft and still being designed. So I haven't actually seen any libraries so far that really add support for it. None of the common ones, but that's obviously bound to come. So I say look back in half a year or so, and I think a lot of these tools will start adopting OpenTelemetry.
Nico.
Thanks for all the great questions.
Yes, thank you so much.